Welcome. This is our second meeting. We're going to talk about, actually, it's not Wyvern, it's Wyvern. And if you see WYV, it's not pronounced Wiv or Wive, it's pronounced Wyva. Right, Kyle?
That is on there.
So Wyvern Protocol and Wyva. So there's a bunch of questions and topics that came up during the intro week Q&A. So thank you for those of you who participated and put those there. I feel like they're all really interesting and worth covering. And I also copied a lot of resources that were pasted in the chat here, and I'll probably add to this and send this out as a part of the shared notes. I think just to change it up, I'd love to hear from you all on what's something as you were going through this that you found interesting or weird, or what's something that, okay, I want to go through this rabbit hole for a brief minute or 2 or 5 hours. Any thoughts?
So the first thing that got me interested was just trying to imagine, like, why did Opensea choose? And what I'm just trying to imagine, if I was building Opensea, what functions would I end up calling, and what would my interaction with Wyvern be? And I feel like I have a better idea of that now, but still could go deeper. And then another thing would be that replacement pattern thing I asked a question about, and exactly how that would be implemented and why they implemented it that way. So there's several other things, but those are some.
That's a really good, and it's related to one of the things that I was really curious about, which is how actually is OpenSea related to Wyvern? Because if you look at the GitHub, there's Wyvern 3.0, but then I think it was Abhi, who's in our book club, who found that the OpenSea contracts are actually Wyvern 2.3, which is again interesting because if you look at the Git commit messages from the Wyvern GitHub project, they reference Wyvern 2.2. So I don't understand where 2.3 came from. So it's all very mysterious. Another thing I found interesting was the fee structure. And I think if folks haven't read this fee discussion thread that Kyle posted, it's actually really interesting because it goes over a few different options. And I think just the way that they deliberated and picked one was really fascinating.
Did they end up going with?
So basically, I think that one of the ideas that they proposed was that there's a protocol fee in the form of Wyva tokens. And so if somebody pays for an asset, then it needs to be whatever payment currency they used needs to be converted into Wyva tokens. And then this part's a bit confusing. They either hold it and it represents their stake in the protocol, and there's an optional switch to turn on a protocol fee. So some of it's allocated to the protocol and some of it's allocated to the relayer. So the relayer in this case would be like OpenSea. It's like the app that lies between the protocol and the end users. But they didn't end up going with that. I think what they ended up doing was the fee is paid in the same currency that's used to purchase the asset. And I think it's optionally the relayer can pay the protocol. Did anyone else who read up on it, did you gather the same thing?
I think that's the thing I got out of it too. They decided to make the protocol optional. Just kind of like leave it up to whether they want to pay it or not. That's a way of making it a public good, but still in a way, OpenSea did the same. They were like, we have a mechanism to pay OpenSea. We have it turned off by default.
Kyle, you're breaking up just a little bit.
Sorry. OpenSea has something where there's mechanism to fund OpenSea in the future, but it's turned off by default and the community can't turn it on if they elect to for future development.
I thought OpenSea, I read in their docs, they took a 2.5 commission on every trade.
I'm talking about OpenSea 2 or V2 or V3.
Oh, most recent version.
So. Yeah, so V3, I was talking about V2. I'm not sure about V3.
I thought they took a fee as well. But is there a DAO for OpenSea that decides, like when you say the community decides whether to turn on the fee? Oh, I didn't even know they had a DAO.
Originally, they didn't have a token, but then SushiSwap came out and they had a token, and earning Sushi tokens was a big deal. And so OpenSea dropped a token after that. If I'm not mistaken, that's my impression of what happened. And that token is related to the ability to vote on that.
Yeah. Anyone else get a chance to look at the protocol, or at least any curiosities that came up? Or maybe you can even share why this was an interesting protocol to look into, why you felt like, okay, this is a meeting I want to attend.
Opensea using it is interesting. Also, it's contract book club. I'm just going to look at whatever because I want to talk to people about stuff. I thought there's this weird thing where there's can be a delegate call or not delegate call, which is, like a head tilt moment.
Oh man, I spent like probably 45 minutes with 3 different tabs open trying to figure out how that atomic call, what the arguments they're passing in.
Where's it?
Maximally confusing. I think it's just called atomic match.
This one, right? Atomic match. This seems to be the core.
Oh, we talked about that in the study sessions. You weren't there, Melville.
Yeah, I remember we briefly talked about it. Did we figure out what this entire function does? Because I feel like this is the secret. It's like the core.
So I had a proposal for what it looks to me like it does. I'm curious to hear what Melville did. It sounds like he went deeper. My thought was you put in buyers stuff, sellers stuff, and then if the off-chain, once you found a match, then you basically supply the buyer and the sellers signed like agreement to buy and sell to this. And it confirms that those are actually a match and executes it. If so, is that right, Melville?
Yeah, that high level, that matches my understanding. Because you take in signatures, they call it the order and the counter order, which I think the counter order is the taker, because all the wording seems to be from the perspective, because this is the most important entity, seems to be all from the perspective of the maker.
Should we do a quick recap of maker and taker? So I asked that question in the chat, and I think it's really interesting, especially because maker and taker seem to be important terms in all of crypto or anything where finance or even NFTs, like in this case, it's maker and taker exists for NFTs as well. So should we go over that once in case there's any confusion?
All right, Melville. My impression of this is maker is somebody that makes a market bigger. Taker is somebody who's using the market. Can I say that? Is that wrong?
Yeah. I'm definitely not the fountain of wisdom here. Let's figure it out together. But I know how I've seen it used, and that matches it. I also saw like Abi in that mini discussion we had, he had pointed out that it doesn't have to be a sell order. It can just be a limit order for buying or selling. Makes sense. That made sense for me because you're being a market maker. You are placing a definite price saying, this is what I'm going to buy at, or this is what I'm going to sell at.
Yeah, even if you're
the building block of exchanges
is still an offer to provide liquidity for the other currency. The buy order for the stock or the sell order for the stock, both of them are, they're just like dollars on one side and stock on the other.
My understanding of maker and taker is basically someone is saying, I want to buy this thing or I want to sell this thing. Taker is just basically just taking that order. So as Melvin says, maker is basically just making the market. It's different than like a bid and offer, right? Bid and offer is a like specific thing, either right, the price at which the market will buy the currency pair. And the offer or ask is the price at which someone is selling the currency or any other actually instrument.
So in the case of Wyvern, my thoughts on Wyvern is the maker are people putting up objects for sale. But are we saying that the people putting up objects for sale as well as people putting up like open buy orders for anybody who's going to sell something after both makers? In which case, who is the taker? So I would think if you put up an offer.
Oh, yeah, Cameron.
I was just going to say that there is a distinction here with NFTs because each individual item is different. So from that standpoint, it does make sense to me that you could, whether you're placing an order for buying at a price or selling at a price, that you're the maker, and then whoever's filling that order is the taker, whether they're on either side.
So the person who initiates the action is the maker, and the person who responds to it is the taker. Have I made it more confusing?
No, that makes sense actually, because these are market, right? You sell, you just put something out there. So the way Opensea works, basically, you can always put a bid, but whoever has the item, they can maybe take that offer or they do not. So that's at least my understanding. I haven't used it extensively.
Yeah, the thing is you can put open buy orders too, where you can say, I will buy any Bored Ape for this price. If anybody wants to sell their Bored Ape, I'll take any of them. You can even be more specific, any Bored Ape that has VR glasses and things like that.
Here's an idea. What if maker is synonymous with risk taker?
So the maker is the taker. Wow.
Maker takes, God dang it. The maker has risk.
Okay. Hold on.
Because in the same way that a market maker takes risk by putting out both buy and sell orders, usually a market maker on Coinbase, they're not just placing sells or buys, they're doing both. They're making money off the spread.
Ironically, market maker usually has the least risk. Actually, the takers who do take the risk, I think that actually does work. Usually, if they're playing both sides of the market, they're just collecting fees on every swap. So that's not a bad way.
Maybe this is because I'm too DeFi local, but
yeah,
like when I think about swap, definitely the risk takers are the LPs because they're using
I know what you mean.
Algorithm they have impermanent loss. Whereas traders, they just snipe in when there's arbitrage or maybe they have some extra information going to help them profit. So in my mind, that makes sense where the makers are the risk takers because they have to like lay the thing down on the table first and then the takers come in.
I would say though, fundamentally, I don't think, I might be wrong about this. I don't think we're going way off the rails here. Maybe I should stop this. How does maker and taker relate to our Wyvern discussion again? Where did that come up?
That's the terminology actually Opensea uses. So I just found the documentation where they define who is the maker. So a maker is the first mover in a trade. Makers either declare intent to sell an item or they declare intent to buy bidding on.
Okay.
So taker is the counterparty basically.
And the taker is the person who takes the offer.
Just
cool.
Yeah,
that was my original thought. Okay, we just leave it at that. Perfect.
Kyle, I think we're both happy. We both come away there with thinking our definitions make sense. So I thought the same thing.
Because I said maker initiates the action. So I think we converged.
I was saying if there is a way to share the link, there is no chat enable, right?
No, maybe just share it in the general chat.
Nice. And then just to close this out, I pasted this from somewhere. I actually think Melville, you pasted this in the chat. And as a relayer, I think this is actually what's been implemented. As a relayer, so if you're OpenSea, you have control over maker relayer fee and taker relayer fee. Maker fees for asset sellers, or you can just read this if you can see it.
I think I posted that about
or you posted,
to think of what's a maker and what's a taker. And this was from some chat of theirs. Yeah. And so, they mentioned the taker who will always be the asset buyer.
Another thing that came up that we can talk about is the replace pattern part, because Kyle, you mentioned I can put up a buy order for any crypto. So that's something that was in the white paper, but I don't know if I saw it. Is it in the exchange protocol as well? I don't know if I saw replacement pattern specifically.
So if I remember right, in 2 point whatever, and the docs about the change that that maybe one of the things they mentioned is actually changing, but I don't recall now.
I think this is the thing that 3 has that 2.0 doesn't have. So there's this really good document on what's changed between 2.2 and 2.3. And I think there's, let's see.
Yeah, functions over the space of possible calls. And I think possible call, that refers to the fact that buy CryptoKitty 1 and buy CryptoKitty 2 and buy CryptoKitty 3 may all fall in the space of possible calls that fill a certain given order. I think that's what they're trying to indicate there. As well as like one of the possible calls will be sell to address 000, sell to address 01 to infinity, right? All possible unit 256 or whatever, all valid addresses. Those will all be in the space of possible calls. I'm willing to sell to anybody, for example. So I sign off on this range of possible calls. And so the idea of the replacement pattern is you say which parts are interchangeable with any value and which parts are like fixed. Like it must sell from me, it must sell from this contract, and it must be a sell. So it has to be that function call, but it can be any of my NFTs from that contract, and it can be to anyone who's willing to pay me, right? Or something like that.
Did anyone read the version 2 protocol? Because I spent all my time reading version 3, and I don't see anything in version 3 with replacement pattern.
I think it probably was taken out. I think that was one of the cool ideas they had in 1. And I think they kept it in 2, but I actually spent most of my time in version 2. And
I basically think that they just had this really cool idea and they're like, man, this would be so efficient to do bit masking to communicate possible function call ranges. And they just thought this is so neat from like a coding perspective and ran with that. But then I think they just were a cool idea, but it doesn't need to be done that way. And
the world's not ready.
Yeah, I think they just wanted, go ahead.
Oh, I was just going to say, this part is interesting, how it solves this problem by moving the call data unification procedure completely off chain. It makes me appreciate they reached for this level of complexity and flexibility, but also makes me appreciate the relayer in between that needs to really understand how to work with the contracts to access this infinite flexibility.
So actually reading this section right here that you have and the paragraph right above it that's highlighted, this kind of seems to me like it's talking about exactly what we're talking about. This original bitmask concept is very cool and is very capable of this limited set of options. But in theory, you really need a function to express all of the possible ranges of what people might want to give a fully open. I'm willing to accept CryptoKitty 1, 3, and 7 as long as they have red eyes, whatever, or I need one that's between these numbers or between these numbers. And it just starts getting the range of what people might want to put an order for as like a potential buyer. It's just not fully captured by that. And I think even from the beginning, they had both. And eventually they're like, if we have both, we don't actually need the other one. Let's just take out the bitmask option. So that's why I don't think you see it in V3.
Cool. Other questions that came up. So we talked about this. So the proxy registry contracts, I think this part's actually really interesting. Has anyone read up on this and wants to talk about what they gathered from reading the proxy registry contract stuff?
Yeah, the fundamental idea is that if I put up a sell order or a buy order, the other person come along and there's not like any back and forth that's needed. There's just I put up my one thing. Okay, I have this thing for sale if any conditions, or I have a buy order open for any of these conditions. And then somebody come along and just, bam, they completely fulfill it. And in one transaction, the full trade happens. They don't need to go and like ping you. I'm willing to take it. Here, I'm going to send it to this escrow, and then you send it to that escrow. And then once we've both done that, then it will send it to both of us when we call the claim function. No, you don't need any of that. Instead, whenever you're ready to put up a sell order, you give a contract, a proxy, what do they call it? It's just a proxy.
There's authenticated proxy.
Yeah, so you have register proxy deploy an authenticated proxy on your behalf, and then you hand over ownership of your asset to it, and you set the terms to it, and it basically becomes your arbitrator, and it is willing to sell on your behalf anytime somebody meets the appropriate conditions. And that gets registered to a registry. So now it's like holding it on your behalf and can sell it on your behalf. I think that's a fundamental idea, and they're calling it proxy, which is confusing because it does not have to do with the delegate call, which is what we mostly associate that word with. Instead, it's like actor on your behalf, use proxy, not like delegate call.
So what about that couldn't be done with an EOA? Can you scroll up, Padmini, and we'll just scan the functions in this code?
Yeah.
So it has this like home base registry. You can revoke it. That's another question. And then it just has the proxy call, which is just a arbitrary function call. Why couldn't that be done on an EOA? Why is it important that it's being called here? I'm asking you to repeat yourself, but I didn't understand your full explanation.
Where's the entry point? Is the entry point proxy registry? Is this what's initiated by the EOA? Is this what starts the entire
atomic match?
Atomic match is actually the top. Yeah. Should we go back to that and then trace it?
Yeah, that would be helpful.
Okay.
I think it's an underscore, but maybe there's some
underscore calls this.
So it should be down in execute call. So line 348. And then if you go and look at execute call,
or is execute call from?
You just control F, execute call. I think it's defined in here.
There.
Line 252 is the one that calls proxy.
Oh, registries. Assert valid registry. Oh, it passes in a proxy registry entry.
So basically, you get the authenticated proxy for that address, right? And then you call proxy.proxy on that one with the call target and the call data. and that's what executes order. That's the last line in this function. That's where the magic happens. So we get a target, a mention to do it as a call, and call data. So I guess we can go look at the proxy function.
Is this function clear?
Basically,
trusted?
that whole thing is like a lookup function. Just look up what is the appropriate, go to the registry, put in the address of the maker, and
whether it's
proxy.
trusted.
Yeah, because they control the registry. They only put in the proxies into the registry, make it through them. So anything in that registry is.
So why is that needed? I think that's the part I'm not understanding, is what's gained by not having the call executed by a EOA. That's not even possible, but like, what's gained by having an allow list? Which is what this is.
Allow list. You mean?
Yeah, it's like saying these proxy implementations are what we trust. And what are we protecting? Yeah, what's the attack if we didn't use these?
It could just be random code. Right now, they have a proxy factory that makes these proxies on behalf of people know what code is in those, and it's safe code. All the code in those registries and all the code that they're going to touch through this, it could just be any arbitrary code otherwise.
That makes sense, like a kind of defense in depth. We're not sure exactly what sort of shenanigans you're going to get up to, but at least by using the proxies, it drastically reduces it.
I also read something about how giving the proxy, the authenticated proxy contract access to your assets makes it easy to upgrade things around it while still keeping your assets in one place. So that's another, I guess it's also like storage. I don't know where I read that, but I know that's a thing. It was specifically in one contract or document.
That makes sense. I think actually the term that people use these days for this concept is vault. I think this is basically can be thought of as a type of vault.
And a vault is a contract that holds something for you that only you have access to.
A contract that holds some asset on your behalf. And that contract usually is a part of a larger protocol and has special conditions and terms for when you can get it, put it in, and it can move. It's a proxy function. That's what gets called. And this is where it gets fulfilled. I guess to try and answer your question, Melville, if we didn't have this, if the asset wasn't held by a proxy on your behalf, is that your question? Like, why do we need a proxy to hold the asset on our behalf? That's how I interpret it.
Exactly. That's it.
So if that wasn't the case, then we have to ask, how would we go through this process? So I go to Opensea. Oh, hey, this guy wants to sell this Bored Ape for 100 ETH. I'm down. And then what? I can't just click buy. What happens when I click buy? If it's owned by an EOA, the Bored Ape contract doesn't specify like a whole marketplace functionality. It's not like I can write onto my Bored Ape what the buy price is and anybody can take it if they send that money to me. Bored Ape contract doesn't facilitate that. It's not standardized anyways, even if it did. It's not built into the ERC 721 standards. They would just have to contact me and say, hey, I want your Bored Ape. I'm willing to do it for 100. I have to see it, say, cool, send it to me. And then that person's beholden to me. Like all of a sudden I'm holding the money and they're not holding it. We can't do that. So now we need an escrow contract. So now we're going to have to deploy an escrow contract where I send the Bored Ape and the escrow contract waits for them to send 100. And whenever it gets both, it sends them both to the opposite person or something. And it's basically a pre-programmed escrow contract that holds your one asset on your behalf. You can pull it out and anybody can put in the other side of the trade and get it out.
So would the flow be like, if you're a taker, then prior to actually settling the trade, you would have needed to transfer your payment token. Let's just say it's USDC. You would have had to transfer that into your proxy. And then
no, if you're the buyer, you don't need a proxy. Only the seller needs a proxy.
We can go through that here too and see where that happens. So after this validation, it looks like
only proxies.
Maybe. So,
right,
so our discussion around it was very useful. Our 20-minute discussion around makers and takers. So here we are sending either to the maker, that's right, or not maker.
This block I understood because it says up above on line 339, it says this is the first asymmetric part of the order matching. An order requires ether, it must be the first order. And so they're making a big deal of how it's going to be asymmetric. Oh, it's going to be awesome. And then we see the horrible secret in the code, which is that they needed to break that a little bit. When I said asymmetric, I meant symmetric. It's no matter, it doesn't matter the side. I remember them saying that in the V3 docs. But here we're seeing it's not true because there's two asymmetric parts. And just for whatever reason, when they designed this, they realized, okay, we need F to come in somewhere. So we'll just arbitrarily decide it's going to be the first order. So
yeah,
that just needs to be decided. It doesn't really matter, but you need to follow it. So that's why they have that first ether sent in there.
I'm not sure 100%, but it seems like just swap does this thing where they just check which side is which, and then they run with it and they assign things. Seems good at something like that. I'm not sure I understand actually why it says asymmetric here. Can you explain what that means here, Melville?
Yeah, so can you jump to where those V3 docs were?
Yes, just give me a moment. Okay, here we go.
This is not.
Oh, sorry, I meant
yes,
wyvernprotocol.com.
Okay.
/docs.
So out these.
And those would be two docs. We've gone through
I think
white paper, which is like.
I think it's back to the upgrading from Wyvern 2.2, and then it's the protocol components section on the left.
Okay.
Yeah. But so scrolling down, sorry, it was the upgrading from Wyvern 2.2. So here where it says capability improvements, symmetric bidirectional call matching. So this was them saying, oh, we don't have these kind of weird asymmetries where like these first order always has to, or the what did they say here? One side always had to be for F. They said that somewhere here.
Sell side orders execute a function call. Buy side orders paid for the execution of the call with some ERC20 token.
Here's what it says. Order schema could not express trade intents with no ERC20 side. So that's an asymmetry. So they're saying, we got rid of these asymmetries. Life is great. Look, so beautiful. But then we go and look at the code. And like at some point, the caller of the function who's passing in the message.value, that message.value that's passed in needs to be sent to the necessary recipient. And I guess it's whoever the two, if you go back to the code, Padmini.
Sorry, my tabs are getting out of hand. So let me see.
So just so you know, on the top right of your window, if you click that down,
no. Oh my God.
it lets you search for your tabs. It's incredible, I know. So you can just type.
My God. Okay, this is great.
I blow everybody's mind when I show them this feature.
I feel like, to Melville's point, I feel like a really interesting, arguably interesting part of looking into this protocol was the whole mystery of it. I feel like all of us were detectives. We're like, which one is Opensea actually using? Where is this contract on GitHub? Is this the same? Is it different? How is just this big mystery?
Why does
Opensea has a DAO? What's the fee structure? Like, why am I reading a thread?
So close. Yeah. The white paper, what version is that for? Where are the other white papers? Okay, no white papers.
Yeah. Why is it a work in progress? Is it a work in progress for V3 or V2 or just a working document?
OpenSea V3. What's going on here?
Yeah.
That was the biggest question because I felt like maybe reading V3, I thought at first it was not going to be, this is a better choice. But now I'm thinking if that audit is from 2018 and it's been 4 years, this thing is not going to ever be released. So I should have just looked at the V2, but here we are. It's fun.
Yeah.
If you go to the project root of this and then go to audits, I think it's audit spec. This is not useful.
It looks like they never got.
And the decenter.
Is this an auditing firm?
And it's like the dinkiest audit you've ever seen.
Well, it's 2018. Something else I noticed with these old audits, they look older. Like audits have improved over time.
Yeah.
And the demand and spec for how the reports look has changed. But that's so crazy. That means V1, V2, and V3 were all released in 2018.
Wow.
Like 2019. They were all released within like a year. But so when did OpenSea launch? Was that also 2018?
17.
Oh, it was 17. Okay. Really?
I think so.
Actually, wait, when did CryptoPunks come out? It was 2017.
It was January 2018.
But it was finalized in June 2018. But I guess people were using it before that.
Yeah, I feel like I'm comparing these to the audits I got in Shipyard. And then this seems really short compared to what I've gotten.
You'd be surprised. There's a lot of variation in length I've seen them. I just did an audit for a protocol and I had 19 pages of what I produced for them, but they had another audit that was done for them that was like 3 issues.
Wow. To me, my general interpretation of that is that you were probably way more thorough.
That was the comment I kept getting from them. Like, wow, this is.
I can imagine they saw the one with 3 and they were like, great, we're all good. And then they see yours and they're like, damn it.
No, it was still good. It was still mostly good quality and low issues. They did have one severe issue.
One thing I wanted to actually talk about, because I read this as I was looking through this doc, is smart contract ownership swaps. Does this happen often where you transfer ownership? And is this a functionality that how would you implement this?
You could have a function. And think about it. You have the set owner functionality in the contract, and you can just basically set up another contract that says, hey, if you put money into that proxy contract, it will call the set owner to your name on it. And then bam, you're the owner of that contract. Why would you want to do that? There could be lots of reasons, but just to give one, it's incredibly basic and I think easy to understand. You could have, and this was a cool idea. Actually, so my audit assessment was looking at a real client that had tried to do this before I came. The idea of having a kind of wallet for things. And if you basically, let's say I have 100 assets you want to buy from me, rather than paying the fees to transfer all of them, I have a wallet that owns them and I just send you the wallet. Now you own the wallet. So we just transferred all like 100 assets in one transaction very easily. And in that case, you just want to transfer ownership of a contract. So that's the reason why you might do that.
I'm thinking about Ethernot's stuff, and it seems like, how would you make that secure? Make the set owner, do you say only this proxy contract has access to calling set owner, or how do
you would make the
that
proxy
type?
the owner? If you're using like ownable and only the owner can set the owner, then you would give ownership to that proxy contract. You also then on that proxy contract give permission to you to set it back to yourself through the proxy contract, right?
I also thought of it, Kyle, you had answered this question a while ago in the chat, but so I had read that article by Vitalik, and in it he had mentioned about how if you want to create something like the naive solution for making something soul bound, you just say, okay, the caller is now the owner and no, it can never be transferred again. Right. But the way you get around that is by not transferring the asset, but transferring the ownership of the contract that owns the asset, which would apply here.
Exactly. So like the wallet idea I just mentioned, you make that the owner instead of the actual EOA the owner. If there was some way to say only an EOA could own this, no contract can own this. But if you do that, you break a lot of composability and all of a sudden it can never be owned by a multi-sig, for example. Or it can never be owned by one of these. There's these ideas of these wallets that are not just a multi-sig, but like in case you ever lose your keys or there's ever some problem, we can help you recover it, but we'll never be able to do anything without your permission type scenarios. Those are also implemented with smart contracts. You just kill any innovation on that space if you do that. And so if it's ever compromised and smart key compromises and losses happen, then you're stuck with that. So then you need like the whole social support kind of concept, but now we're going into that rabbit hole. How do you do soul bound?
If some item is a soul bound, you can maybe sell your soul as well. You can just empty all other items. You can empty all other items except that one item which you want to transfer and then give control of that wallet to whomever you're selling your soul.
Yeah, you just go down to Georgia and you enter a fiddle battle. And then your NFT is transferred to the Delta.
Real question. How has there not been some smart contract protocol called Horcrux at this point?
Are you sure there has?
No, it was probably made as I voiced that question.
Would that be similar to fractional?
Exactly. I don't know much about fractional NFTs, but it seems like that would be the key name.
So when I think of the Horcrux concept, for me, it's okay. I decided for my backup, I only have memorized my private key. I just memorized it, and I won't have it written down anywhere. But I did think, what do you do in case of death? And I thought about giving pieces of my private key to different people I know. And in the event of my death, they're like able to come together and try the possible permutations.
That's the way to go.
And
I'm part of one of those. So, old coworker told me, like he gave me, it's called Shamir secret sharing. And it's a way of splitting up a piece of data so that you need like a multi-signature, you need N parts to come together to reconstitute it, really decrypt it.
Nice.
And he gave me one of the Shamir secret shards with the idea that if he ever dies, I'll hear about it. And then we'll have maybe his wife or family member will be someone who we can talk to. Hey, I'm one of the secret holders. Tell me who the other ones are, and we'll come together and give you his crypto.
Which you don't realize, Melvin, I've been tracking down all the pieces of his Horcrux, and I just got one.
Yeah, no wizard.
I feel like there's a good product idea in there because I actually do think about post deck a lot in the context of Web3 because I feel like it's pretty resilient. And plus, if all of these projects evolve and there's DAOs, I do feel like maybe the combination of all the NFTs I own and all the DAOs I'm a part of could be representative of who I am. So I do feel like there's a product idea in here somewhere, like replicating the whatever shard. What is it? Shamir shard?
Shamir secret sharing.
Shamir's thing.
You can type it in the tab or in a new tab.
Yeah.
And
Oh, nice. It's like math.
the greatest
Yeah.
part is it's high school math. It's stuff.
Oh, it's
yeah.
I don't know, Melvin. I see a Sigma.
We hate the we hate the, what is it? It's not Sigma, it's the other one. Pi.
I think it is capital Sigma.
But
And
the
this is
basic
definitely-
idea is if I have a line, how many points do I need to tell you are on the line before you can totally uniquely describe the line?
Yes.
And if you have a parabola, which is the next like order polynomial, you just need
Mhm.
3 points. So the way they implement it is the points are like the shards. And if enough people come together, you can have enough points to uniquely determine the curve or the polynomial. And then the coefficients of that polynomial are the key.
And I'm such a genius. I did this without math. Don't call me Vern.
So there is a lot of talk in the chat around this function, which is checking whether an address is a contract. I did have some questions around this. So these are literally copied from messages in the chat that I wanted to revisit, which I don't fully understand the vulnerability.
First of all, how did they use exists in this contract? Where does it get called? I'm just curious. I want to see if they're trying to.
Yeah.
Because I expect
Yes.
they're actually using it fine, hopefully.
Yeah.
But if not, it's because it's old fashioned. And they didn't realize this yet, I guess. So
Yeah. So I think if I recall correctly, it's in maybe here. I don't know where I pasted this from.
Would it,
the function called exists.
Oh, it's here. Yeah, it's in the exchange core.
Okay. Is that where it's
Defined?
That's where it's defined, and it's also called here. It's called in these validate functions. So validate order authorization and validate order parameters. This function's shorter, so we can see how it's used.
look at the what's the other one?
The other one is here, and validate order authorization.
And why did we check his contract as well as signature? Is this P3 we're looking at?
This is V3. Yeah.
So that's using EIP 1271 magic value. So this is that whole thing with the fact that EOAs can have signatures because they can have private keys. But if you want to be a contract, this is the EIP that kind of allows contracts to sign stuff. So that's a valid use for his contract for exists.
What did you say? Secret? Oh, magic value? Yeah. Could you talk about this? I actually don't know this EIP 1271.
Do you know in depth about this, Melville?
kind of, I can give a try at it because I just read it. So the idea is you're sitting there and you have a smart contract wallet and you want that smart contract to be able to use something like Opensea or use any of the types of contracts functions that require signatures. So it'd be like in the DAO project, vote by SIG. But the problem is that a contract doesn't have a private key associated with it. So it won't be able to generate signatures and it just won't work.
It was one of the really few niggling problems with the fact that like having a smart contract be a wallet just like is not quite as capable as an EOA wallet because you just need a signature for some things. So it was just a pain in the ass for a long time.
Yep. It's still a pain in the ass because you need to write all this extra code You could also just go import from OpenZeppelin. They have a contract called Signature Checker, and it implements everything. But basically the idea is, okay, what is authentication? Authentication at a high level is smart contract approving Opensea or Wyvern. So smart contract approving Wyvern to perform some sort of action. And so they implement that by having Wyvern call a function on the smart contract that goes, do you approve of this? Is this a valid signature? And they're able to pass in a signature at all, because remember, smart contracts can't create signatures. But ultimately, a smart contract wallet is going to have at some point behind it an EOA, a regular address. And so when Wyvern calls back and says, is this a valid signature? Internally, the smart contract wallet is through this is valid signature call on 187. It's doing the validation. So like it can trust that its own validation is correct. It's doing the validation to see, is this a signature that was signed by my owner? Or if you have a multi-sig smart contract, maybe it's 2 out of 3 of the signers generated this. It's not going to be just one signature, multiple signatures. But the point is that is valid signature logic is implemented by the smart contract, and it can do whatever authentication logic it wants.
And so as far as that magic value, just to be clear, that's totally arbitrarily defined within the EIP. And it's just it returns that value if it was successful.
I think it's a hash of the signature itself.
I mean, it's declared in, you can look at the EIP, I'm looking at it now, and it's just got this hard-coded value. It's just the magic value.
What's the EIP number again? 271.
That was probably confusing.
Or Vip, did you mean this is a pre-calculated hash?
Yeah, it's a hash of that is valid signature. So that's like a 4 byte.
So there's this kind of like typical standard where you take the 4 bytes of a hash of a string, and the string is valid signature by 32 bytes, the function. Yeah, that's right. I thought it was dynamically related to the signature itself, but no, that's right. It's the function signature. Yeah, I was confused. If you remember from the proxy lecture, they do the same thing. This just, this occurs over and over. It's just a thing people do in Solidity. Yeah, so basically they're saying if it's a contract, we need to do this as opposed to it's an EOA. So what other places do they use exists? Do they use the exists function?
Oh,
yeah, that's confusing.
Okay.
So here, basically it looks to me like they're making sure that the function, the proxy function actually exists. They're checking with the registry. But they're saying, hey, we got this proxy back from the registry as the one that we're supposed to call to, and they just make sure that it exists before they make a call to it. So that makes sense. That's fine.
Yeah, validate order parameters.
Looks like they're doing the same thing.
Yeah, isn't this because like in the Ethereum, even though contract doesn't exist, and if you call it, and it will always return true, I guess.
That is exactly correct.
I think that's the reason they're checking.
Sorry, could you repeat that one more time?
So like I think in Ethereum, if you call some non-existing contract, it will always it's true. I don't know the reason why it does that or what's the reason behind that, but I think some people always check before if the contract really exists.
If you're doing a low level call, then the low level result is just, okay, we did not revert. Yep. You'll just get no revert whenever there's no code there. So these are all fine. Go ahead.
Yeah.
I was just thinking that, yeah. Anyone else? No, it was probably something where they were designing the EVM and they came to this point where if it failed, that would result in some horrible bug or some just like massive vulnerability that it would be a fundamental flaw, is my feel. But yeah, definitely needs more investigation.
I feel like there's been this ongoing confusion in Solidity about whether to handle problems from contract to contract calls with a false, with a revert, like what should we do? And you just keep seeing like the couple of possible valid answers. Am I still connected? Everything is really quiet. I was hearing white noise. Yeah, all the possible valid answers get used. So like the ERC20 standard, there's 2 possible ways that it's totally valid for ERC20 to fail. It can return false or it can revert. They're both valid. People just didn't decide. They just could not agree. And I feel like this is kind of that same thing again.
This is where I think it makes sense for like where Solana uses Rust, and Rust has optionals. They're just, I'm prepared to die on this hill. I think they're the best error handling mechanism that we've come up with. They're better than throwing.
Are you referring to optional where it can be null or it can have a value?
Yep. The basic idea is the type system forces you to check which one it is. And so your type system, you'll never get nulls, and you'll never get, your code will always be acting on whether it is actually an undefined or actually a null or true.
Is it like in JavaScript promises, or whenever you make a promise, you have to declare like a resolve and a reject function? And
it's more on the other side. It's more on the calling side. It's like if promises forced you to await them before you could go and call anything on them, which they do in TypeScript. Like you can't get the length of a promise that returns an array. You need to await it so that you get the inner array, and then you can call length on it.
that's true.
So optionals is like that, but now like anything you can just wrap in an optional. And usually it's done for like a function where it's possible for it to have an error, and any branch in the code that returns an error is going to return the failing version of that optional. Whereas any of the paths that return the true value are still going to return an optional, but they're going to have the actual value, the true value. And then in the context, you need to write a line of code that says, okay, if it's the failing case, do this. If it's the succeeding case, do this.
Yeah, see, Java also has this mechanism.
Yeah, Java. That's what I was thinking. I was trying to remember where I've seen this before. Yeah, that's cool. So I actually want to talk about this particular thing you brought up, Kyle, which is create to. Worth noting, it could become a contract in the future. Now, this is definitely very interesting.
Yeah, just to be clear, I don't think it really has anything to do with the Wyvern Protocol, but I'm glad to explain it. So there's this idea that you could check to see, okay, is the thing I'm calling a contract, and you check if it's a contract by checking, is there code at that address? Like what is the length of the code stored on the blockchain at that address? But there is a way to have code there, and then it's a contract, and then to call self-destruct and have it remove itself. And then the length of the code there is 0 again. And that's indistinguishable from an EOA.
Yeah.
The thing is, if we use create to, then what we can do is consistently deterministically deploy to a particular address. Normally with just create, that's not how it works. Deploy, it's going to take a nonce related to your address and the code, I think. I'm not sure off the top of my head, something like that. But it's every time you deploy, it's going to be to a new address, period. Even if you self-destruct the old one, your new deploy will be to a new one. And that's never going to be replicated. Nobody's going to accidentally deploy to the same thing twice, just like nobody's going to pick the same wallet twice. But if we use create to, then we're allowed to, as long as we're deploying to the same code, and there's even clever ways to get around that limitation. Certainly, easy one would be utilizing proxy stuff. Then you can redeploy to that address. So you could basically make it look like an EOA, and then make it a contract, and then self-destruct and create to and redeploy, and make it look like a contract again. Definitely back and forth. That's what I'm referring to there. It's a contract by looking at it and seeing no code. You also can't, because of the constructor that everybody knows about, which is that somebody could be deploying, and while the constructor's running, it can do things that only a contract can do, right? Run multiple atomic transactions in one transaction, well, multiple atomic calls in one transaction. But if any of those calls says, hey, is the person calling me? Is that a contract? It's going to be like, no, there's no code because I'm actually constructing. And until I'm done, there's no code here. Both good reasons why you can't use that for safety.
Okay, cool. So I think other questions I had that we didn't talk about are, I think we covered this, what happens on-chain versus off-chain. It looks like the order book and the matching, all of that happens off-chain, and exchange happens atomically on-chain. Does anyone else have any other questions? We have about 10 minutes left. And if there aren't any other questions, we could also just end early. Any other things that they want to talk about?
I have a question we can round off with, but definitely would like to hear from folks who we haven't heard from. Darian, Gary, Komada.
Gary's on this call, just lurking back there.
Yeah, I'm lurking here, but I'm just listening here, just trying to absorb everything that you guys been saying.
Hopefully we're not making fools of ourselves up here.
I don't think so.
Yeah.
So, very good discussion so far.
All right, I'll ask my last
Yeah.
question. Is that cool? So one thing I'm still not understanding, and this is in the V3 code, is if you go back to that atomic match function, which I think we agreed on is like the main function for how this all works, they break it up into this idea of a static call, and they have a static target and then a static selector, which is just the function that you want to call on the static contract. And it's actually farther down. Also, just side note, we're taught to follow checks, effects, interactions, but then for some reason they do checks, interactions, effects.
Admin brought that up. Yeah, it's funny. I see this sometimes too, but they do explicitly have a reentrancy guard, which is why this is possible. I don't know. I didn't look close enough to figure out if there's a good reason why, but I have seen cases in code I've audited where it's like you can understand why it really would have been awkward for them to do checks, effects, interactions.
Same thing with Uniswap. Aside, on line 353, it says static calls must happen after the effectful calls so that it can check the resulting state. So these are confusing to me, and I'm not sure why they implement it this way, because on line 362, they do the first static, which has something to do with the first order. And what it does is, obviously it's a static call, so it's not changing state, but it's returning a fill value, which I want help on understanding this, but my grasping at an idea was that the fill value would be for an NFT would be 1, because there's just one NFT, where if you had an ERC20 token and the order was for like 100F, the fill, you could do partial fills, and so it would be some number less than 100, like 50. But even assuming that's true, I really don't get the static call part.
Yeah, this is interesting. I feel like what they're basically saying, the reason we're doing it, we execute it first above with the execute call on 4851. Then they do these, and static calls, these are like read-only checks afterwards to like get some like post-order stuff from the proxy. And I don't know what that is though. We could look up like, what is it actually, what is the function that's happening here? And what's the value that gets returned?
So we could jump to that. If you go to the directory that this is in, Exchange, and oops, sorry, it's in contracts.
Is it in?
And it's in static. Yep.
Okay, static.
So I think what I pieced together is go maybe static ERC20 or static 721 is a good one to look for. So
yeah,
if you look at these functions, these are like all the permutations involving an ERC 721 that you could do with an ERC 721. So like you can swap an ERC 721 for an ERC 721. And is there another function further down?
There's transfer exact.
Actually, I do not know what these are. I was looking at a different static one. But what they're doing is they're checking to make sure that the data that was passed in is of a certain form.
So if you go back and look up execute static call, which is probably in that same contract.
Oh, yeah, there's one here. Right.
So we have static call uend. I forget where that's from. Might be here as well. Look about it. Okay, so it's,
I think it's
static caller.
Static caller.
Yeah. I should have put this in an IDE like you did.
The target and data, and it just does a static call with data to a target.
So pretty straightforward.
So let's go back and look at the way it's used. So target, and then encode static call. So it's just going to encode. That's just going to make some transaction data probably and send it to the target. That's going to be the data in the target. And what are we taking in?
I don't think we have enough time to decode this. I was sitting here for about an hour trying to step through, and it helps to start with the tests.
Yeah.
And look at where they're calling atomic match in the test. And
so
then just follow the call chain.
Just scrolling down to the bottom of this function, I'm just going to glance at this. So order is matched. So that's the thing. The order is matched. Well, no. Okay.
I think that's just a guess.
Can you scroll up and see?
Yeah.
Order dot. Where do we do this assignment? What is that value it's drawing from? Where is first order dot maker first hash first being defined?
That's
Is it
a
pulling
storage
from it?
variable.
But where is it being defined? This particular, the first hash value.
First hash order.
Yeah, it's just a unique ID for the order.
But they're setting a value to it somewhere. And now we're comparing it and expecting them to match. So it's like,
No, that it'll be default to 0. And so I think that nested if, it's just don't make a nest store if you're just going to write the same value to the.
I think that it's just a funny name, previous first order fill, instead of like empty first order fill or something. I don't know. And it also says fetch previous first.
But it could be partially filled. It doesn't have to be FD. So like a previous atomic match could have updated it from 0 to 50 when each order has something called a maximum fill, which is just like you want to trade 20F, your maximum fill is going to be 20.
Okay. So if the fill is changed, then update it so that it includes the output of this fill. I guess it looks like to me, it's running like a dry run of that same call and like percent filled result or filled result like you're talking about, and then just storing it for next time. And then does it check this value at the top to the side something?
Oh, could it be, maybe I'm way off, but is it like when we implemented the liquidity pool and the LP contract, and what if there's some logic around that this contract isn't exposed to? So we want to fill a certain amount, but what actually gets filled is something we're not aware of because we can't look into that contract. We're just executing a call somewhere else, which is why.
You mean like in the LP when it tries to get the balance?
Exactly. Is it something like that?
That's my best guess so far. It's like a static call that basically checks, did the swap work? Did I get what I wanted? And it can't tell if it got what it wanted because that's happening in some external call, which it doesn't know about. But yeah, I'm like 40% sure on that.
This was really good. It was really fun just chatting through this. I'll add some additional notes to this file. And if you guys have any more stuff to add that I may not have covered or any other resources, feel free to add them here.